Okay, so we go talking about feature subset selection. Feature subset selection is applied when to reduce the dimensionality of your data. What we mean by dimensions? Dimensions means features. Right? So if you say you have two-dimension, so if someone says, let's say I have two-dimensional data set, let's say two-dimensional data set, meaning, what does it mean? Mean we close. Exactly. So that means your data has only two features, maybe X and Y. Okay, so dimensions means refer to the number of attributes or features. Okay, so as the name indicates, feature subset, meaning we are looking to have subset of the features. Maybe you have quite many features inside your data set. And of course, if you have many features, what happens? The process of training everything becomes very slow, right? So you may decide to select only fewer features than the overall number of features. So another way, we are reducing the number of dimension of data. Or maybe behind the scene, the reason behind using feature subset selection is to remove redundant features. Okay, redundant feature. What we mean by redundant feature, I think we didn't talk about this before. What we mean by if we say we have redundant features, meaning the information found from one feature, it's already captured by another feature. So they are kind of redundant to each other, not duplicates, not necessarily duplicates. We're not saying like I have exactly same values under, let's say, x1, x2. Okay, and I already know x1 actually is equal to x2. Okay, but what we mean, as it says here, duplicate much or all the information contained in one or more attributes. Example, maybe example can help here. We have tax paid between sales and tax paid. Okay, so if you check the equation, sales tax, okay, and tax and purchase price, sorry, here between purchase price and sales tax. Okay, now what information exists inside sales tax, if we like to ask in this way? Sales tax has purchase price multiplied by ratio, tax ratio, right? So in other words, sales tax has already included purchase price. It's already there. If I have only sales tax feature, I can at any time extract purchase price by dividing sales tax by tax ratio, correct? If I assume inside my data only I have sales tax and I want to extract purchase price, I can. Just I take sales tax divided by tax ratio. So you may find out, not necessarily you may go and remove, but you may try and see. As I said, always trial and error. But this is the concept behind redundant feature, where one feature like sales tax has already captured the information of purchase price. It's already there inside. It's just by multiplying the values with tax ratio. Those redundant features, in other words, they may cause a problem as well when you are running your analysis. Okay? Because if you calculate, because of what's called mathematically, if you like to search about, what is the term? Multi-collinearity. You can look for this concept. So when you have redundant features, where one feature, I'm talking between two features, one feature has captured the information from another feature. So you may have what's called in statistics multi-collinearity. Okay, that means these features have relationship among each other. Both of them are input, and yet they have relationship between each other. So actually, if you calculate the correlation between sales tax and purchase price, you should find the correlation is high. Correct? Right? Because any increment in the purchase price is going to be incremented sales tax by the value of purchase price multiplied by tax ratio. So there's correlation among them. And if you have correlation, high correlation among input feature can cause what's called multi-collinearity. Okay? Okay, and since we have redundant, so it may contain no information. Sorry, this is different thing. So we already here talked about redundant feature. Now, contains no information that is useful, like, for example, if you have ID. This is different thing, huh? But still, the reason behind feature subset selection. Let's say you have information, you have attributes inside your data set that is not useful, like ID. Okay, or you're trying to predict, let's say, the house price based on what? Maybe, I don't know, find something not relevant. I don't know. I'm trying to think of something not relevant. Anyway, like ID, let's say house ID, the easy way. House ID. Okay, so house ID, if house ID is just random value assigned, then definitely no meaning. But if the government has assigned ID with a specific format, maybe indicating the location, indicating it might be useful. So you need to understand your data. That's why we have data understanding stage. So here an example like student ID often is considered irrelevant features. Okay, not redundant. You see there's difference between saying redundant feature or irrelevant feature. Irrelevant meaning has nothing to do. Like maybe predicting the student performance based on their favorite color. So what? If I like red color means I have higher chance of having high score. Then maybe now I like blue. So I try to change my behavior to like red color. No, it's irrelevant features. Okay. Now feature subset selection. This is the concept I explained to you. How you can apply it, there are different approaches. Approach number one, which is the more intuitive way, you go and select by yourself. You look for the features that you think they are more relevant to your task and select them. Okay, this is under which one? The filter approach. The filter approach, meaning maybe you go first and apply correlation. Remember in practical session, we applied correlation into the features. Maybe I select those features that have high correlation value. So this is what's called under filter approach. So if you say filter approach, that means you are pre-selecting some feature based on some criteria, like correlation. Okay, so that's why it says here, selected before running the data mining algorithm. Before you run the machine learning algorithm, you select those features in advance. So in other words, the machine learning algorithm will see only the selected features, has no idea about the other features. Okay, clear? Now, when you do prediction, which features you need to provide values for? Only the trained features. If I dropped ID, I drop purchase price, then when I need to predict, I don't pass any values to those because the algorithm has no idea about those features because filter approach. Okay, so you have to pre-select those features before, okay, so please highlight this before running the machine learning algorithm. Okay, like what we have done in probably similar to practical, but we didn't implement it fully, where we calculated correlation first, and then what we do, we select the attributes no, this is talking about pairwise correlation, huh? This is different. To ensure no redundant data, different, huh? Be careful. In practical session, we calculated correlation, right? But between which features? Anybody can tell? When we looked into correlation value, between what set of features? We had what feature we calculated correlation. Which feature was this? Which feature was this one? And then we looked for correlation value. What do you think? Again, no judgment, but anyway, I start to fed up, by the way. Maybe eventually I'll just give class and leave. I already tried for 5 weeks and you still resist to talk. But only the person to blame is your friend because she's not accepting to have penalty 100 ringgit. You see? If you accept 100 ringgit, now all of them will talk, chanting like birds inside the class. Right? Yeah. You said no 100 ringgit. If you say 100 ringgit, everyone here now is talking, chanting. Oh, you see? So the one to blame is her, not me. I tried my best. Though the money, I'm not taking it from myself. Okay? Yeah, so this is for, again, back here. It was among, anybody come? Remember, it was between input features and output, correct? So this is why we found last time like income was the correlation of income with median house price, right? Median house price. What was the correlation? I remember 0.67, something like this. Correct? So do we need, that means we need to drop income? No. Income is very good predictor. Also, some people call these predictors, huh? So there are many terms, make someone confused when you are reading. Anyway, so income is very important. You don't drop. The case here is different. We're talking about pairwise correlation, meaning between, we choose another color, between what? Input versus input. Like we said, sales, what was? Sales tax, the earlier slide, and purchase price. All right? Those among two inputs. Now, as we said, if you have high correlation, that means you have redundant features, and you may end up with multi-collinearity. So if you have that big problem concern, you may decide to drop one of these features. Okay, so that's why what it says, you should look for as low as possible correlation among input features. If you like to make it clear, among input features to ensure you don't have redundant features. Okay. How to remove. This should be for removing, right? Ah, useless. Okay. Now another approach, which is wrapper, right? You like to talk in American accent, wrapper approach to find the best subset attributes without enumerating all possible features. Okay. Or before we come to this, because this is more to explain about, let's just for a moment forget about this, go to the embedded approach. Maybe this is more easier to understand first. So filter approach, we do some calculation, we perform correlation, whatever, then we decide before running the machine learning algorithm. Embedded approach, sorry? Yeah, so machine learning algorithm will do. That means the algorithm itself has the capability to select some features. Okay, it has the capability to naturally as part of its algorithm, such as one of those algorithm, I'm not sure if the name mentioned here, embedded approach, apply embedded feature selection approach. Or no, one of the algorithms is what's called lasso or decision tree. Yeah, here you already given an example, or you have lasso also, lasso regression. Okay, when we talk about regression, you will find out why. Okay, but simply, if you want simple, if you remember, regression is about finding line equation, right? Let's say y equal what? Theta 0, right? Plus theta 1, x1 plus theta 2 x2. Right here, x2, for example. So those embedded approach like lasso regression, let's say it has found out that x1 is redundant of x2, for example. Then what's going to do? It's going to find theta value. If you check theta value, theta 1, you're going to find it 0. So that means 0 multiplied by anything is 0, as if the algorithm has selected only x2 and has ignored x1. Clear? So this is, we call it embedded, meaning by itself, self-determined for the features and removing redundant features. While filter approach you do, embedded approach the algorithm does. Okay. Now the last one is wrapper approach. Okay. Wrapper approach, simply you don't know which one. Here we do some educated guess, as they say. We calculated correlation. We have done maybe something to figure out, right? We have done some educated guess. I mean, our guess here, which feature to remove or to stay, is based on correlation. We have some evidence that these features maybe are redundant, so we remove. But wrapper approach is like the blind approach. What do? Just you start, let's say if we take forward selection. Okay, meaning this is, let's say, my algorithm, and I have, let's say, 10 features here. What do? I start only selecting one feature. I select. Okay, maybe if we draw, let's say I have F1, F2, F3, and this is my model. So in forward selection approach, what we do is going to come and consider F1 first only, and then check the performance. Let's say like accuracy, whatever. Then include F2 second time. So retrain again, including F2. Now, if performance has increased, has become better, we keep F2. If performance has dropped down, then we remove F2. We include F3. Then train again. We see if F1 with F3 has improved the performance, then we keep. If not, and so on and so forth. So it's like just try and see. Just try. Okay, like blind approach. Just try, check, try, check, try, check. There's no calculation or anything you do. I mean, not pre-calculation like correlation or whatever. Okay. Okay, ladies and gentlemen. Okay, good. Okay, backward elimination is opposite. You go and start selecting all the features, F1, F2, F3. You calculate performance. Then you drop one of the features, let's say F3. Then you run again, train again the algorithm. Then you select, you see performance drop down, you put back F3. Have improved, you keep F3 out of the equation. Then maybe you drop another feature, let's say F2. You see performance increase or decrease. Increase, you remove completely, permanently. Decrease, you add back, and so on and so forth. So one is forward, one is backward, and one is bidirectional, where it keep adding, dropping, dropping, and so on. I mean, it may go with many combinations, going forward and going backward at the same time. But keep in mind, this is time consuming, right? If you have 100 features, imagine, because you are training the algorithm 100 times. On all combination, you may get, even actually if you have 100 features, maybe you may have more. So wrapper-based selection approach include assessing the importance of feature using specific algorithm. So in other words, you have wrapper approach with the machine learning. As I said, you keep add, assess, then add or drop, assess. Okay, so you need to keep doing this forth and back many times.